Hello everyone. Today we are going to learn about what machine learning, deep learning, and neural networks are in this machine learning tutorial. What is machine learning? Machine learning is basically an algorithm that uses statistics to find patterns in massive amounts of data. Machine learning generally deals with data in huge amounts, basically thousands, 10,000s, millions of data. This data can be anything that can be stored digitally. This can be images, videos, text, numbers, basically anything from clicks to videos to images. Anything that can be stored in a digital format can be used for a machine learning model. Machine learning is generally categorized into two types: supervised and unsupervised machine learning. So basically, what machine learning does is you have a model. A model is basically an algorithm. You give it some data to train it to learn from. Once the model has learned from that data set, you give it new data set and it predicts the results for the new data set. So basically, in supervised machine learning, when you're training the model, the training data set has some truth values or the results associated with the training data set. Um, so, like, suppose you have houses and price of houses, and you want to see what a new house will go for. How much will the new house go for? So, in case of supervised machine learning, you'll feed it with the data set of suppose hundreds of houses and what their prices looks like. So once you feed a new house in the training model, in the supervised learning model, it will predict the price of that house. In case of unsupervised learning, these houses won't have any price associated with it. I think this won't be a very good example for unsupervised machine learning, but yeah, for unsupervised machine learning, you will see like there is some text in a book and you want to write a new book using just your code. So basically it'll feed it thousands and thousands of book and there is no target value. So basically it will just read through these books and identify the various grammatical constructs of the languages that the books are written in. So when for your book give it a starting sentence or a starting word or a starting character, using the grammatical constructs and words learned through all of the other books that it was trained with, it will start generating characters and words and sentences that can be used for your new book. So on your left, you see a SVM model, which basically has two classes of data, dots and stars. And it uses a line. So this data is linearly separable, and thus it uses a line to just separate the two types of data into two different classes. Moving on to deep learning. So basically, deep learning is machine learning on steroids. Deep signifies the many layers that are present in the model. So basically, deep learning is the ability by which the machine learning models can find and amplify the minutest of patterns present in huge amounts of data sets. So this ability is basically called or facilitated by deep neural networks. So on the left, you see a simple like a what deep learning looks like, kind of a flowchart. So there is an input layer, and here's where the input comes from. Then there are different hidden layers. These layers depend upon how you want to build your model, and the data passes through all these layers, and then through the output layer, the predictions are made. So moving on to neural network, what essentially is a neural network? So we know that deep learning is facilitated through neural networks and it has many types of layers. But what are these layers made of? So neural networks are generally, actually not generally, neural networks come from, their name comes from the patterns of resemblance of the human brain. So human brain, the smallest unit is what is called a neuron, and similarly the smallest unit of a deep learning model or a neural network model is a neuron. So a neuron is what these layers are made up of. Many of these models even have memory, like our brains have. Say, for example, recurrent neural networks. So on the left, you can see a recurrent neural network model, and here is like xt minus 1, xt plus 1. These are basically inputs at various time steps, t minus 1, t, and t plus 1. So analyzing the input at at time step t, the input is xt. The processing is happening in the form of ht, and you see this does not just take the input from this time step, it also takes input w from the previous time step. which is t minus 1. So this is what memory is. What happened in the past is contributing to what happens in the future. So recurrent neural networks are generally used for text generation, an example that I gave in the very beginning of what unsupervised learning might look like. So text generation is what recurrent neural networks are often used for. Convolutional neural networks are generally used for image manipulation and data that deals in images. And then there are feed-forward neural networks, which look like recurrent neural networks but are simpler. So for any machine learning or deep learning model, the main question is what the data set is that we're dealing with. So here we're gonna take the example of Mimic3 dataset. So what Mimic3 dataset essentially is medical information mart for intensive care 3, version 3. It's a large freely available dataset made available by MIT Massachusetts Institute of Technology's laboratories. It has de-identified health-related data associated with over 40,000 patients. The identity of these patients are concealed by changing their birth times, death times, discharge times, stuff like that. The gap between the birth time and death time or discharge time remains the same. They have just been pushed way into the future to conceal the identities of these patients. These patients were admitted in the ICUs of the Beth Israel Diagnosis Medical Center between 2001 and 2012. On the left, you see a simple table. Actually, none of the tables used in the dataset are simple, but this is the overview of an admissions table, which contains some IDs related to the patient, then the admission time, discharge time, death time, admission type, insurance, language, marital status, ethnicity, diagnosis, expire flag, chart events, etc. Moving on to the code. So we are going to learn how to basically code a basic simple machine learning model. So one of the main libraries used in machine learning models is sklearn. So sklearn has its own website, and all you need to do is you just type the model name followed by sklearn in the Google search, and you can find a detailed page of what the model does, how should you write the code, what kind of parameters it expects. So quite a detailed documentation of each and every model in each and every function associated with the model can be found. So now we'll move on to the code. We're not going to run the various code blocks because it takes a lot of time, because the data set is pretty intensive and heavy. So what we start with is actually by importing our libraries. So I've imported pandas, numpy, sklearn, various models, and then the crux of what machine learning code looks like is, so you bring in your data set. So my data set is pre-processed, which I did for another project. Then you just look at what your data set looks like. This is very important because this gives you an insight into what your data looks like. Exploring the data is a very good practice. It also helps in what kind of model would be suitable for your data set. So what my aim here is to take the admissions table. Actually, it's not exactly the admissions table, a little pre-processed admissions table. It has some data related to the patients. And then using this data, I want to predict what kind of insurance do they have. Is it private? Is it general? Do they have no insurance and stuff like that? So basically my target variable or my prediction variable is insurance, and the rest of the columns that are in the data set or in the table are my feature variables. And my features are basically the data that I'll use to train the model, and target is basically what I'm trying to predict. So here my target is insurance, and everything else is my features. So I have called my target variable y, and I'm assigning the insurance as my target variable. I'm calling my features as x, and I'm assigning everything but the features, so dropping the columns insurance, everything but the insurance column as my feature variable. And then what I do is I create training and test data set. So basically you don't want your model to see all the data at once, because you want to check how your model is doing. So you just train your model with certain amount of data, and so that's what the data that your model sees, and then you feed it with the new data which you have set aside initially, and you see how the model performs with this data. So we just call the train test split function, which is which is afforded by sklearn, and then you just split your data into train and test. The training data set is 80% and the test data set is 20%. So here I have mentioned that the test size is 0.20. Then these are the steps that you'll follow for any machine and building any machine learning or a deep learning model. So first, what you'll do is, after splitting your data, you'll instantiate the model. So to instantiate the model, this is just a random variable. And then I've instantiated the linear regression model. Here you can pass all the parameters that you need to or want to pass. Here I'm just planing a basic vanilla model. Then I'll train the model. So for training the model, most of the sklearn models come with dot fit function. The fit function is what is used to train the model. So in the fit function, I'm passing my X train and Y train, my feature trains, my training features, and my training prediction variables. Now, I want to see what the predictions look like. So I'll pass my test variables, test features, and use the predict function to see what the model predicts. Now I'll test the model, like how did the model perform. So I'll evaluate the model. So for evaluation, there are various metrics, like some common ones are accuracy, which is often called score, precision, and recall. So one of the most common ones is accuracy. So I'm going to use accuracy here. And to calculate the accuracy, we use the score function, and inside that we pass the test features and the test predictions. So basically, I pass the test features, I pass the test target variables, and the predictions are automatically calculated because we are also passing the model here. So once you call the score function, this will calculate the accuracy of how a model performed. So these are the basic steps. To summarize, I would say you bring in, you import all the libraries, then you bring in your data set, you properly explore your data set, you split it into train and test data sets, then you instantiate your model. After that, you train your model. Once your model has been trained, you do the predictions, and then you check the accuracy of your model. Once you've checked the accuracy of your model, then you can fine tune the parameters and the hyperparameters if you have passed any or if you wish to pass any. So this is the basic crux of what a machine learning or deep learning model looks like. That's it for the tutorial. These are the references, the various internet websites and books that I referred to while making the tutorial. Thank you so much. Hope you enjoyed it.